For 8-1, day 1, we're going to focus on sequences, and I know this 8-1 is called sequences in series. Day 1, we're going to talk about sequences. Day 2, we're going to talk about series. So a sequence is just a number. A sequence of numbers is a progression of elements with some type of order or pattern. So you're going to have a bunch of numbers, and there's going to be some pattern to it, and they're going to be grouped together in some way, and that's known as a sequence. Here's the general form of how we express sequences mathematically. So we're going to have all of these terms. The subscript indicates what number term it is. Okay, the general term or the nth term is a sub n, or an is fine. And then if we see the braces around it, that means the entire sequence an. Okay, so for example, down here, this entire sequence a sub n, here's my first term a sub 1, second term a sub 2, a sub 3, and so on to a sub n, whichever term you want it to be, and then it just keeps going forever. This is known as an infinite sequence. If it has an ending and it doesn't keep going, then it's called a finite sequence. And we'll look at some examples of all of those here in a second. For the most part, I'm going to go through some examples so you get a sense and a feeling for how this is supposed to work and what it looks like and that kind of thing. So these are some of the types of problems you're going to see. You're going to be given a sequence, and it's going to be defined a certain way. So a sub n equals 3n squared minus 4. Okay, and so the directions are asking for the first 4 terms, and it's defined by the nth term, which is a sub n. So I'm looking for a1, a2, a3, and a4, and we're going to use this formula to figure out what those values are. And then notice how this subscript corresponds to the variable that's in the definition. And so essentially all we're going to do is be plugging in 1, 2, 3, and 4, and then I'll get my first 4 terms. Okay, so again, what I'm looking for is when n equals 1, when n equals 2, when n equals 3, and n equals 4. And I will just tell you, for sequences and for series, that sometimes the subscript can have a different variable. It doesn't always have to be n. It can be any variable that the problem gives you, and then it'll correspond to the variable in the definition, and then you'll be looking for the first, second, third, and fourth term when that variable is something different than n. Okay, so essentially all we're going to do is we're gonna find a sub 1, a sub 2, a sub 3, and a sub 4, and I've relisted the a sub n, and we'll just write that again. So really all I'm going to do for the first term is I'm going to plug 1 in for n, simplify that, and then I'll have a sub 1. And so here's what that looks like. So I'm substituting 1 in for n, right? Then I have to simplify this, so this is 1 squared. We do the powers first, so this is 3 minus 4, which is negative 1. So the first term is negative 1. And then you just go through and do the rest of them. So go ahead, pause the video, and see if you can simplify the next 3 terms, and then come back to it and let's see if you've got it correct. So hopefully for a sub 2 you plugged 2 in for n. Looks like that. So this is 2 squared, which is 4, times 3 is 12, minus 4 is 8. And a sub 3, I plug 3 in. 3 squared is 9 times 3, 27, minus 4 is 23. And then lastly I plug in 4, and I get 16 squared, 4 squared is 16, times 3 is 48, minus 4 is 44. So here are my first 4 terms, and then I just write those out. And I won't get too hung up on whether or not you write it out or you just have them listed like this. It's pretty obvious which are the 4 terms. So that's part of what we're going to be doing in 8.1. The other thing that we're going to do is find a specific term. So instead of saying, okay, the first 4 terms, they're going to tell us, hey, I want to know the 8th term, and that's it, or the 15th term, without having to find all the other terms first. So that's what this example is about, finding a specific term. Okay, so in this case, they want to know the 6th term, b sub 6. So same process. I'm just going to plug 6 in instead of having to do all the other ones. I just plug 6 in, simplify this, and see what we get. Now recall, here's a factorial symbol. When we were working in statistics, we learned about factorial. So we're going to plug in 6, And so really all I'm doing is substituting 6 for n. And so I have 6 squared over 6 plus 1 factorial. Okay, so that's 36 over 7 factorial. Now if you remember factorial, this means 7 times 6 times 5 times 4 times 3 times 2 times 1. So I'm going to write that actually out right now. Okay, now you may be able to simplify this on your calculator, which is fine too, but I do want this as a fraction. The problem started off as a fraction. Your answer should end up as a fraction. Now what I'm going to do is pull some of these factors together that equal 36. So see if you can figure out which factors together combined will give me 36, and then cancel those out. That'll make life a little bit easier. Alright, so if you notice 6 times 3 times 2, which is 6 times 6, those will cancel all out. And then so I've got 1 left on top, and I've got 140 on the bottom. Okay, so 20 times 7. And so that's how so the sixth term is 1 over 140. And I can find that without finding the first other 5 terms. The next thing that you're going to have to do in 8.1D1 for sequences is you're going to write a sequence defined recursively. And what recursive means is use the previous answer to help us define the next answer. So for example, what you need is the first term. And then let's look at this definition. A sub n equals 2 a sub n minus 1. What this means in relationship is if you think about it, if I subtract 1 away from n, this term ends up being the term right before this term. So for example, if I had a sub 8, the term right before it is just 1 less than it, a sub 7. And the term right before that is a sub 6. So if I just take where I'm at and subtract 1, I get the term before it. If I take where I'm at, subtract 1, I get the term right before it. So that's what this formula is really saying. It's saying that we're going to use the term right before to help us figure out the term that we need right now. And so that's what recursive means. We're going to use the previous information, the previous term, to help us find the next term. Okay, and so this definition is a recursive definition. So the reason why this is important, that I need the first term, is because that's how I'm going to figure out the next, in this case, 4 terms. So I've got the first term already, and then so I'm looking for A2, A3, A4, A5. And I can't find A2 from this formula unless I'm already given the term right before it, which is A1. So for example, if I'm looking for, okay, so there's the first term. And that's basically everything that I was just explaining, okay? So this is the value of the nth term, 2 times the value of the preceding term, the term that went right before this term that we're looking for, times 2 plus 1. Okay, so to find a sub 2, I need 2 times the term right before it, plus 1. And in this case, the term right before a2 is a1, which they gave us, so that's 4. So all I'm doing is I'm substituting 4 in for a sub 1 here. Okay, since this is the term I'm looking for a sub 2. The formula tells me, okay, it's 2 times the term right before it. So the term right before it plus 1. Okay, so now we need to find a sub 3, a sub 4, and a sub 5. So in order to find a sub 3, I'm going to need a sub 2, which we just found. So this is that process. All right, now I just found this, so now I'm going to use it to find my next term. And so what happens is, again, a sub 3 equals 2 times a sub 2. Again, 1 less, or the term right before it. And the term right before it was 9, so I plug that in and I get 19. Go ahead and pause it, find a sub 4 and a sub 5. So it's just the same process. So a sub 4 is going to be 2 times a sub 3 plus 1. A sub 4 equals 2 times a sub 3 plus 1. A sub 3 we found up here, so I plug it in. That gives me 38 plus 1 is 39. Then a sub 5, same thing. Now I take this 39 and I'm going to use it to find a sub 5. So a sub 5 equals 2 times a sub 4, which we now know is 39. So that's 78 plus 1 is 79. So there are my first 5 terms. So this is how we use a recursive formula. And again, recursive means I need the answer right before it in order to find the next answer. And this is that explanation. Okay, the preceding term, a sub n, and then the term right before it. And so this is all the stuff that you're going to be doing on day 1.